Dear colleagues, the infectious inflammatory diseases caused by the opportunistic microorganism is a growing problem of 21st century. Unlike pathogenic bacteria, they are part of normal human microbiota. Many of them are difficult to culture or non-culturable. Moreover, mere detection of opportunistic bacteria doesn't point to their etiological value. This slide shows the role of opportunistic microorganisms in the development of urinary tract infections. Even in uncomplicated cases, 1/4 of all cases are caused by opportunistic gram-positive and gram-negative anaerobes other than Escherichia coli. In complicated diseases such as pyelonephritis or urosepsis, the variety of opportunistic bacteria is even wider. On this slide, you can see the most significant and most often detected opportunistic bacteria. They are represented by three classes: bacilli, beta-proteobacteria, and gamma-proteobacteria. Culture-based methods generally used for the detection of opportunistic facultative anaerobes have a number of disadvantages. They often lead to false negative results or incorrect analysis results. Decentralization of sample collection is problematic. Fastidious bacteria might die during transport and escape detection. The real-time PCR-based kit BacScreen OM allows us to detect and quantify 25 opportunistic bacteria. The kit determines the total bacterial load, TBL, and identifies gram-positive bacteria belonging to 3 genera of Bacilli class. 18 gram-negative bacteria are detected by the kit. They belong to Enterobacterales order and to Pseudomonas, Haemophilus, and other genera. Now, let's have a look at an example of the BacScreen lab report. Please turn your attention to the result output format. Each value is given quantitatively and measured in Lg genome equivalence per sample. First, the total bacterial load TBL is calculated. Then the proportion of each microorganism to the TBL is calculated. Note that if a bacteria of the Streptococcus genus is detected in a given sample, there is a Streptococcus agalactia. Streptococcus species value would also have to be positive. Similarly, Staphylococcus species value always would be positive if Staphylococcus aureus is detected. The same goes for Enterobacter class and Enterobacterales. Enterococcus, Acinetobacter, and Haemophilus species were also found in the sample. What is most important is that we get the information about the dominant bacteria in the sample, the one with the highest proportion in TBL. In this case, it's Staphylococcus aureus. Also, we determine other bacteria in each sample which can potentially participate in the inflammatory process after the elimination of the leader. The kit is recommended for use by a wide range of medical professionals. It can help with timely and precise identification of the pathogen causing the infection and thus allow the specialist to select the appropriate therapy for patient. Different human bacteriological material can be used for testing. All options are presented on the slide. It's important that testing by means of the real-time PCR is less demanding on the conditions of storage and transportation of the specimens compared to other diagnostic methods. So, the use of real-time PCR allows us to identify the species and even the quantity of opportunistic microorganisms in various samples with high sensitivity and specificity. Another serious issue facing humanity and mankind in the fight with infectious diseases is resistance to antibiotics. We all know that antibiotics can save lives, and so the middle of the 20th century, when the first antibiotics were discovered, has become the golden age of antibiotics. Both antibiotics and vaccines dramatically changed the mortality structure as well as dramatically increased the human life expectancy. However, each new antibiotic drug is met with the appearance of resistant strains. For example, methicillin-resistant Staphylococcus was first registered only 2 years after methicillin was developed. This is why today reasonable prescription of antibacterial therapy today involves identifying whether the detected microorganisms are resistant to antibiotics. Only this can ensure effectiveness of therapy of patients and slow down the global spreading of resistances. There are 2 groups of methods for laboratory diagnosis of antibiotic resistance: phenotypic and genotypic methods. The phenotypic methods have several limitations, such as strict requirement for pre-analytical stage and their time and labor-consuming methods. On top, we can observe false negative and false positive results that do not correspond with in vivo effectiveness. In contrast, the genotypic methods allow us to detect the origin of antibiotic resistance, even dormancy-resistant genes in bacterial genome. The development and launch of the BacResista kits, which are available in 2 versions, became a breakthrough in antibiotics-resistant testing. This slide lists the resistance genes detected by the kits and their corresponding antibiotics. The BacScreen blood test is suitable for detecting antibiotic resistance in both gram-positive and gram-negative bacteria, while BacResista GLA1-MAC test is only the gram-positive bacteria and was developed to detect methicillin-resistant Staphylococcus aureus. Different human biological material can be used for testing. All options are presented on this slide. It's important to know that testing by means of the real-time PCR is less demanding on the conditions of storage and transportation of the specimens comparing to other diagnostic methods. That makes the procedure more robust and allows the decentralization of sample collection. This slide shows 2 examples of lab report. For BacResista GLA1-MAC kit, a qualitative test result is shown, while for BacResista GLA kit there is a calculated quantitative assessment and automatic conclusion. For example, in this case, genes of resistance to beta-lactam antibiotics were found, resistance to penicillin, cephalosporins, and monobactams can be observed in gram-negative bacteria. The kit is recommended for use by a wide range of medical professionals. Enabling timely and precise detection of genes of resistance to glycopeptide and beta-lactam antibiotics, it can help doctors to choose the optimal therapy for each patient. In contrast, the phenotypic analysis real-time PCR is fast and reliable test. It detects all resistant bacteria, including those with silent genes that are not yet phenotypically determining. The line of BacResista kits was developed to be combined with the kit BacScreen UPM. They really complement each other and can be performed using the same primary biomaterial and can be run in parallel. However, our resistance kit can also be combined with our real-time PCR kits like Enderflor and Femaflor 16. When gram-positive and gram-negative facultative anaerobes are detected using this test, identifying resistant genes to select the right personalized effective therapy is absolutely justified and recommended. Thank you for your attention.